Hello everyone, this is me Nadika Powder and today I'm here explaining about transformers and large language model. So everyone uses ChatGPT every day, right? And you also use various voice assistant devices like Alexa, various recommendation systems, various chatbots. So what is the architecture behind all those applications? So today here I introduce transformers. So let us learn about transformers with the simple task. Suppose you want to translate German to English. So transformer is an encoder decoder architecture. So you supply the input to the encoder and compute the output from the decoder, which is the target sentence in English, and the input is the source sentence in German. And this in transformers we have 6 layers of encoder and 6 layers of decoders. So the input from the first encoder is the output from the first encoder is passed through the second encoder. The encoder further consists of self-attention and feed-forward neural network, while the decoder has one additional element, that is encoder-decoder attention. So now let's dive into self-attention. So moving back to this same example, translating German to English. So let's look at how a human translator translates German to English. So here see does not memorize the whole sentences in German and translate like sequentially into English. But what here she does is like translate some of the initial words or sentences into English, and now if he or she wants to look back, he or she can access the rest of the sentence, understand its meaning, and then translate it into English. So self-attention. So why it is called self-attention? Because it attends to itself, that is the sequence attends to this same sequence. So here the word eat, it has more relation with the animal because it refers to the animal. So it gives much weight to the animal while giving less weight to the words that have less relevance to the given word. However, it attends to all the words in the sequence and computing the weighted sum at the attention score. So how self-attention works? So every word is assigned with query, key, and value. So query is the word that wants to attend to all other words. Keys are all other words. So when we look into the traditional lookup table, so the query is matched with one of the keys to give the value as the output. While in attention, the query is matched with all the keys, but the score is based on the relevance with all the words in the sequence, and the output is computed as the weighted sum. So whenever we have a sequence, we tokenize it and then pass the tokens to the self-attention, and it is then passed to feed-forward neural network, and the output from the first encoder layer is passed to the second encoder layer. Now we looked into, so we have an input, we compute the input embedding, which is the computing the vector, and we compute positional encoding, and here we have multi-head attention. So why multi-head attention? So we have a number of heads in transformer to calculate the self-attention scores. So why multiple number of heads? So here I have the sequence. I went to Stanford CS224 and learned. So here the query is the word learn, and it attends with all the words in the sequence. However, this word Stanford, CS, and 224 has higher score because this head is attending to entities. So it is computing the entity relationship, while this head is looking to the syntactic because the word I went and learned have similar syntactic relevance. So this has higher scores. So one head is computing entities, the another head would be computing syntactic, and there would be number of heads. Similarly, one would be computing long distance relationship, other would be computing short distance relationship, and similar context. So that we can compute all the complex relationship in the sequence, like syntactic, semantics, entity, dependencies, etc. So decoder has the same elements, while it has the additional component, that is encoder decoder attention element. So now we'll learn our transformers. So where are transformer used? It is used in large language model. So what is then large language model? So before we jump into large language models, let us understand what is language model as a whole. So language modeling is the art of predicting the next word. So let's look at this example. I went to dash. So here we want to predict the next word based on the previous sequence, that is I went to dash. So the next word can be shop, market, office. So it predicts the next word based on the previous context. So then what are large language models? So large language models are large general purpose language models that are pre-trained on general tasks and fine-tuned for specific tasks. So here the word large refers to both the large data set as well as the large number of parameters in the model. Then what are these jargons? Pre-training and fine-tuning. Suppose you want to be a great chef. So where do you start with? You start learning, you go to the cooking school, start learning all cooking various dishes. So you have the knowledge of putting various ingredients in various dishes, and you learn cooking as a whole. This is pre-training, because you have the basic idea of cooking. Now you want to be an Italian chef. So now you use that knowledge or skill learned, the general cooking skill, to cook the Italian cuisine. So this is fine tuning, because you are using the knowledge learned through like the general cooking skill to cook Italian dishes as a great Italian chef. Similarly, in large language model, during the pre-training, we train it with a large number of dataset given from text documents, websites, etc. So here the model learns the general understanding of the language, like word embedding, syntax, semantics, and contextual relationships. So it accomplishes this by language modeling, where the model predicts the next word given the previous words. Now this general understanding of language is used in specific works, like specific tasks like sentiment analysis, text classification, machine translation, etc. So during pre-training, a huge dataset and a huge computation resource is required. But during fine-tuning, we use a specific task-specific dataset and a less computational resources. So the general understanding of language is used in specific tasks like sentiment analysis, text classification, etc. during fine-tuning. So now we learned about large language models. So let's look at what are the large language models that's available. So now the popular example, ChatGPT, uses LLMs like GPT-3, 3.54, etc. And we have Llama 2 by Meta, Mistral, and Jafar LLMs. And we also have other greater number of LLMs which you can use for your tasks. So that's all from my side for transformers and LLMs. Hope you could grab the concept. So that's all. Thank you.